Um, my name is Heba Jarboon, and I'm going to tell you about scatter plots and data analysis today, and I hope I really help you. So, in this lesson video, we're going to construct and interpret scatter plots for bivariate measurements data to investigate patterns of association between two quantities, describe patterns such as clusters, outliers, positive or negative associations, linear associations, and nonlinear associations. We're going to know that straight lines are widely used to model relationships between two quantitative variables. For scatter plots that suggest a linear association informally fit a straight line, and informally assess that a model fit by judging the closeness of the data points to the line. Use the equation of the linear model to solve problems in context of bivariate measurement data, interpreting the slope and intercept. Understand that patterns of association can also be seen in bivariate categorical data by displaying frequencies and relative frequencies in a two-way table. Construct and interpret a two-way table summarizing data on two categorical variables collected from the same subjects. Use relative frequencies calculated for rows or columns to describe possible associations between the two variables. And so let's start with two-way tables, because those are what I feel are the easiest. Two-way tables show the data from one sample group as it relates to two different categories. And in a two-way table, you have to interpret relative frequencies, and a relative frequency is the ratio of the number of experimental successes to the total number of experimental attempts. Relative frequencies can suggest data too. This is what a relative frequency looks like. Not relative frequency, a two-way table looks like. And it's not this empty, but just for your learning sake, we're going to fill it out together. So, we would just fill in these x's, which is pretty simple. To find our first row, you would do 78 minus 57 and get 21, and you just put that in where the x is. And for our second row, we would do 13 plus 9 to get your total, which is 22. And so now that we're not all the way filled in, we would just add all of these up to get the rest of our total. So that'd be 57 plus 13 would be 70, and 21 plus 9 would be 30, and 78 plus 22 would be 100. So now we're all filled in, and we can make relative frequencies. Relative frequencies are, we already know this, and to find them, you write ratios of each value to the total in that row. So that'd be like 57 to 70, because 70 is the total in that column, or 57 to 78, because 78 is the total in that row. So you could just put that with all the rest of the numbers in the table and pretty much figure it out. So I already made your relative frequencies, because it's really simple. You just simplify your ratios and turn them into percents. And if you don't already know how to do that, look at some of the other videos on this channel, and those might be able to help you out. So now you can make a conjecture using these relative frequencies about your data. So one of the conjectures I made are that there are more people with cell phones than people without cell phones. And another one would be that more people have MP3 players and a cell phone than any other category. And if you look at the percents, you can see that MP3 player and cell phone owning people is the highest percent there is out of all four categories. Now, just for I don't know, help you concentrate better at the task at hand, I covered up the other row just like I did before. And I didn't do this one, but I was hoping you might want to try by yourself, so please feel free to, at this point, pause the video and try yourself. But anyway, let's move on. So then we're going to look at scatter plots, which is where that data from those two-way tables go. A scatter plot shows the relationship between bivariate data graphed as ordered pairs on a coordinate plane. Bivariate data is data with two variables or pairs of numerical observations, and that's what a two-way table shows, bivariate data, and the scatter plots show your bivariate data. So there are different types of scatter plots. Different types of associations. There's positive, negative, and no association. Positive association is when the x increases as the y increases and it goes upward, and negative association is as the x increases as the y decreases and it goes downwards. No association is when there is no obvious pattern and you don't really know what's going on because everything is just really random and really all over the place. There's also linear and nonlinear associations. A linear is when the data points lie close to a line, and nonlinear is when the data points lie in the shape of a curve or not really by any line in particular. There's also two more terms that you might want to know when looking at scatter plots. There's an outlier and a cluster. A cluster is a collection of points that are closer together, so it's just data that really looks like it's in the same place and it's really similar. And an outlier is data that is really not the same as anything else and it's just really off and really different from everything. Now we can figure this stuff out if you're having trouble interpreting your plots and stuff. You can use something called a line of best fit. The line of best fit is a line that is very close to most of the data points. And if you want to figure out if it's linear, just look at the definitions and you can put 2 and 2 and see how those can help you out. A line of best fit helps you find the association of your data. I just told you about that, and it also helps you make a conjecture about the data. And I used that term before in the video when I was talking about two-way tables. A conjecture is a statement that is believed to be true but has not yet been proven. So it's kind of like an educated guess, but like a more factual educated guess. Now let's try making our own conjecture with a scatter plot. So first you make your scatter plot and then you draw a line that best represents the data, which is your line of best fit, and I have that already done in blue. So then number 2, step 2, we find the slope and the intercept of the line of the y-intercept of the line of best fit. And so to find slope you do m equals rise over run. And first you have to find 2 points anywhere along the line of best fit, but it has to be on the line of best fit, alright? It doesn't necessarily have to be any of the already given points on the plot, just on the line. So then you would figure out your rise and your run, and so you'd look at where your first point is, your lower point, and you'd get 150, and you would look at the y of your second point, which would be 275, and you would just subtract and get 125. Then you would look at your x's, and so you have 3 and 9, so you just subtract 3 from 9 and you would get 6. So you do rise over run and get 125 over 6, and if you simplify that into a decimal you get 20.83. Then you have to find the y-intercept, which is where the line of best fit touches the y-axis. And the y-intercept can also be represented in a b, and forgot to mention it before, the slope can also be represented with an m. So the y-intercept is 87.5 because that is where it touches the x-axis. Now you have to write your equation, finally getting to the good stuff. The equation is supposed to be written in slope-intercept form for the line of best fit that it is drawn. So the slope-intercept form is y equals mx plus b, and I told you that m is equal to slope and b is equal to y-intercept, and we already know the slope is 20.83 and the y-intercept is 87.5. So now you just plug them into the equation, so y would equal 20.83x plus 87.5. I'm pretty sure you're wondering why we haven't plugged in that x or anything in there, but that's because you need to know what your conjecture is going to be about. My conjecture is about how many subscribers there's going to be in 2015. So I need to figure out how many years from 1999 to 2015. So that would be 2015 minus 1999, which would give you 16. So now you just plug in 16 where x is, and you just solve that out, and you'd get y equals 420.83. Now you can make your conjecture using the information that you have. So I would say in the year 2015 there will be about 420.83 million cellular subscribers. That would be my conjecture. Of course, now we would probably be able to prove that because we're already in the year 2015, so, But that is a conjecture. It's really just an educated guess, or with facts and evidence and all that. But, yes. Now let's try problems on your own. I put in a scatter plot. There's something about the slope and intercept form, and there's also a two-way table. I hope you can figure these out on your own, and I hope I really helped you. Thank you for watching my video again, and I really hope this helped you, but if it didn't, please feel free to look at any of the other videos on our YouTube channel, and maybe those can help you, but I really hope I did. So thank you so much for watching this video, and I hope I helped. Whew.